Moving on to next problem. We are asked to convert 1250 inch cube per day. Inches are written as IN in short form, inch cube per day, to centimeter cube per minute. So the first step is to fill the respect relations table to solve this problem. So in this case, we have to convert inch to centimeter cube. So we know 1 inch is equal to 2.54 centimeters. So this is the relation which connects inches and centimeter. Coming to day, 1 day has 24 hours. So we have to convert day to hours. Each hour has 60 minutes. So next step is to draw the table and fill the respective value. So the first cell will have always a numerical value, that is 1250. The second column has inch cube in the numerator and day in the denominator. Now let's fill the respective relations in each column, starting with inch. So 1 inch is equal to 2.54 centimeter. By the way, the inch is cubed here, so I have to cube the centimeter also here. Since inch is in the numerator, I have to keep the inch in the denominator. So I can fill like this. So 1 inch is equal to 2.54 centimeter. I have to cube this because I have cube here. 1 inch cube in the denominator, 2.54 centimeter cube in the numerator. So moving on, 1 day is equal to 24 hours. Since I have to cancel the day, I am writing the day in the numerator, hours in the denominator. Now we cannot stop with this hour. We have to convert this hour into minutes. 1 hour has 60 minutes. Since I have to cancel the hour, I am writing the hour in the numerator, minute in the denominator. So 1 hour is equal to 60 minutes. You can see that these columns are the relation that connects inch and the centimeter, day and hour and a minute. Let's cancel the terms that are present both in numerator and denominator. So first, to start with, inch cube in the numerator, and we have inch cube in the denominator, we can cancel that. Next we have day and day, so we can cancel the day. Then we left out with 24 hour and hour, so these hours can be cancelled. So remaining we have minute. So as far as our concern, the numerator has centimeter cube and the denominator has minute. So I can combine everything and write as one simple equation. So I am multiplying all the terms in the numerator and I am placing here. So 1250 into 2.54 raised to the power 3. Now I have to multiply all the terms in the denominator and write it in the denominator here. So 24 into 60 minutes. So the unit comes to be centimeter cube per minute. On multiplying and dividing, I will get the value 14.22 centimeter cube per minute. Let's move on to next problem. So we are asked to convert 75 pound per hour feet square to kg per second meter square. The first step is to take the relations for each term, so that connects everything. So we are having pound lb in the numerator. We have to convert to kg in the numerator. So we have to find a relation that connects lb and kg. So in the table you can see 1 lb is equal to 0.4536 kg. In the denominator we have hour. We have to convert the hour into second. So 1 hour has 60 minutes and each minute has 60 seconds. Coming to feet square, we have to convert feet square to meter square. So let's find a relationship that connects feet and meter. As per the table, 1 meter is equal to 3.28 feet. So we can use this relation. We filled out all the relations. Now we move on to next step, that is drawing the table. The numerical is filled in the first column. Then the lb, that is pound, in the numerator, and the hour in the denominator. And there is 2 units in the denominator. So I am using the next column also, hour and feet square in the next column. Now let's fill the table with the respective unit relations. We have to convert lb to kilogram. So this is the relation connecting lb and kilogram. Since lb is in the numerator, I have to write lb in the denominator so that I can cancel this. So I am writing the relation in this particular column. 1 lb is equal to 0.4536 kg. Next is moving on hour. So since hour is in the denominator, I have to write hour in the numerator. So 1 hour is equal to 60 minutes. I have written the relation here. So this hour and this hour can be cancelled. But as per the question, we have to convert minutes to second also. So I am writing the relation between minute and seconds. Since minute is in the denominator, I have to write the minute in the numerator. So 1 minute is equal to 60 seconds. So I can cancel minute and minute. You can see that here. Moving on, the last term is feet square. So I have to convert feet to meter. This is the relation that connects meter and feet. Since feet square in the denominator, I have to write feet square in the numerator. So 1 feet square is equal to, so I can write here As per the relation, 3.28 feet square is 1 meter square. So I have written the 1 meter square in the denominator. Now we filled all the data. Let's cancel out all the terms that are present both in numerator and denominator. The first is LB. So it is present here. So we can cancel the pounds. Next is hour. So we have a hour here and here. So I can cancel this too. Moving on, we have minute here and there's a minute here. So we can cancel the minute also. Now we left out with feet square here and there's a feet square here. We can cancel this. Only the feet square will be removed, but the 3.28 will hold the square value. Hope you remember that. Now what I did is I'm combining this and writing as an equation. So all the numerator are multiplied and kept as numerator here. You can see 75 into 0.4536 multiplied with 3.28 square. I am multiplying all the terms in the denominator and putting in the denominator of this equation. When I am solving, I will get 0.102 kg per second meter square. Let's move on to the last problem. So we have to convert 3.5 calorie per gram mole Kelvin to joule per gram mole Kelvin. You can see that the denominator is still the same. Only we have to account for the numerator. So the problem is simple. The first step is to write the relation from the table. So the calorie and the joules are connected by this relation. 1 calorie is equal to 4.184 joule. So to solve the problem, let's draw the table. So in the first cell, we'll write numerical value. Then we write the unit in the numerator, that is calorie. So I have written calorie here. Denominator has gram mole Kelvin. I have replaced here. So now we need not change the denominator. We are expected to change only the numerator. Hence calories in the numerator. I have to write the calorie relation such that the calorie present in the denominator and the other term, that is joule, in the numerator. So 1 calorie is 4.184 joule. I have written here. So I can cancel this calorie and calorie. So remaining I can combine and write it here like this. The numerator is 3.5 into 4.184 joule. There is no numerical value in the denominator, so we can ignore that. On solving, we will get 14.64 joule per gram mole Kelvin. Hence, we converted 3.5 calorie gram mole Kelvin to 14.64 joule per gram mole Kelvin. The next lecture will be on concentration of liquids, where we will be discussing on molarity, molality, normality. Thank you.